Hey everyone, thanks for joining us in today's broadcast. Let's talk about data show. So for viewers who are joining us for the first time, in this show we talk about databases, we talk about analytics, we talk about Gen AI and all things related to data. Today we have another interesting show lined up where we'll be talking about the in-memory solutions in detail. But before that, let me start by introducing myself. My name is Prasad Madkar. I'm a database specialist solutions architect. I've been in AWS for a little more than 2 years, and I work closely with customers on their relational database journey. So today I'm joined with Maria and Paul. So, Paul, would you like to start by introducing yourself?
Hi, Prasad. Thank you. Great to be on the show today. So my name's Paul Ross. I'm a senior specialist solution architect at AWS, and my focus is in-memory database services. So that's Elasticache and MemoryDB. I joined AWS last year. Before AWS, I worked at Redis as a partner solution architect, and yeah, I have quite a lot of experience over a number of years developing software and working with different customers. For example, in higher education and research, I spent a number of years helping universities modernize their applications and do cool stuff on the cloud. That's me.
Yep. Thanks, Paul. Maria?
Hi all, I'm Maria, Solutions Architect from AWS. Um, After everything that Paul said about him, I'm kind of confused. What should I tell? But okay, basically, I became a solutions architect something like a year ago, and before that, I used to be a software developer in Elasticache team in Tel Aviv. So I also have some experience with in-memory databases, and currently I help my customers and other AWS customers building solutions using in-memory services. So yeah, here I am.
Yep. So thank you both of you, and looking forward to this show. So we also have Lydia, who's our chat supporter for today. So if you have any questions, feel free to post it in the chat, and it would be good to understand like where the audience is joining in from. So do post in the chat as well about where you're joining in from, and if you've worked on in the in-memory solutions as well. So yeah, let's get started for in today's episode. Starting with can you both help us explain, what's new in the open source solutions software world with respect to especially the in-memory databases?
Yeah, I can take that one, Prasad. So
Yep.
I think the last 12 months has been really interesting for in-memory database services. Um, if you're familiar with working with caching technology, you might be familiar with
Mhm.
Redis. And uh, it was March last year in 2024. Redis, the company, made some changes to the way they wanted to license open source Redis. Um, and so we've seen a number of companies come forward and create what's called the Valkey project. So the Valkey project is stewarded by the Linux Foundation, and it has backing from a number of leading companies within the technology industry. So AWS is throwing its weight behind Valkey. Google is involved.
Mhm.
You have um, database like managed companies that manage databases in the cloud, such as Ivan. They've got involved with the project, and you've got telcos, for example. So it's really interesting who's come forward to get involved with Valkey, and the fact that the Linux Foundation is involved means that it will remain an open source project going forward.
Oh, that's great. Yep. So you touched upon Valkey. So can you give us some more understanding about like what is Valkey, like how customers use it, and what are the recent announcements or innovations in that space?
Yeah, sure. before we go forward with that, I just wonder, the name Valkey is kind of, I don't know, I heard different feedbacks about this name. So I just, ask people who are watching us now, maybe, put plus if you like it and minus in the chat if you don't like it, because it's really interesting. Like, I heard very different feedbacks, and just wonder what our audience today think. And yeah, of course, I will be happy to share what kind of innovations were brought into Valkey engine. First of all, like, currently there are two versions of Valkey. There is Valkey 7.2, which was basically almost 100% forked from Redis 7.1 or 2, Paul? I think 2 initially. And the next version, basically like final version, completely separate from Redis open source, is Valkey 8. And there are several cool things that were added there. First of all, I think that it's like not a secret for developers that Redis open source is single-threaded. And because Valkey is forked from Redis, so it also was created as a single-threaded engine. And one of the first things that were added there is a support for multi-threads. So they added IO threads that knows to help the main engine to read and write, to proceed with all kinds of system calls, and to let the main engine actually be focused on what it is good at, to run commands and to save the data and process the data. So this is the first thing. The second interesting thing is actually the whole dictionary, which manages the data inside this huge hash table. It was rewritten, kind of, and it helped to save space that previously was used to hold all kinds of pointers. So actually, I heard from our customers who move from Redis open source to Valkey that they actually see it with their own eyes, that the used memory is actually decreased after the migration from Redis open source to Valkey. This is all because this new memory management that was introduced in Valkey version 8. There are all kinds of other improvements, but I think these two are the major ones.
Okay, so apart as a part of this innovations that you mentioned, do primarily customers use it for caching? Like, what are the use cases that you've seen?
Yeah, there are different kinds of use cases. Basically, when we're speaking about use cases, it's not something Valkey specific. It's in general in memory specific. So Valkey doesn't have its own special use cases. So yeah, the most popular use case, of course, is caching. So yeah, like companies just put caching layer before different other databases to decrease, the number of read operations that can be actually very heavy and slow. So cache helps in this kind of situations, but this is not the only case where in MemoryDB they actually shine, because there are many other use cases. For example, if we need a leaderboard for some gaming solution, and it should be real time, right? And people want to see who beats who, what is the score, and so on. So this is also a very a common use case for Valkey and for Redis open source, because it has a data structure that is called sorted set, sorted list, whatever you want to use it, and it actually does the whole compute and sorting inside the database itself. So you don't need to do it on the application side, and because the algorithm is so efficient, you basically just use it and you get all these real-time features immediately. So this is like another example. Paul, do you have something else?
Yeah, those are good examples that Maria's pointed to there. I think interestingly, customers are kind of looking somewhat beyond caching now as well. So if you're an application developer, you can really think of technologies like Valkey as giving you an in-memory data layer, which is distributed, which you can use to do more innovative and intelligent things with your application. So, for example, distributed session management. If you've got a cluster of virtual machines, then you can move sessions to a distributed cache to improve your application performance if you're using load balancers, for example, and you can avoid things like sticky sessions on the load balancers. You can use Valkey lists for queues and stacks. You can use Valkey for distributed locking, pub/sub mechanisms. That's really popular. So, for example, financial services companies. I spoke to a customer recently who's using a lot of pub/sub messaging to distribute messages amongst different applications. You can also do data streaming, so stream data to applications from within in memory, so it's very fast. And you can also do geospatial search within Valkey, which I find really interesting. I used to kind of work on web applications that were using lots of specific geospatial functionality. So to be able to do those geospatial searches in memory is really powerful if you're building kind of modern applications where you need to be aware of things that are going on around users as they move about, for example.
Yeah, and they're absolutely fast as well. They don't need to go to the disk to get to retrieve that data set as well. So
yeah, there was a question in the chat.
Yeah. We'll go into the questions. Yeah.
Does it support sub-millisecond latency? Paul, could you please answer this question?
Okay, yeah. So when we're working with Elasticache, for example, we're typically talking sub-millisecond response times. So we talk in microseconds when we're measuring throughput for the Elasticache service. So it is very fast, and that's because the data is being retrieved from memory, which is on the server.
Yeah, exactly. And because of the multi-threading now in Valkey, it's actually even faster because yes, reading and writing the result also takes time, and now we also speed this up.
Yep. So yeah, now let's look at the chat. We had a few questions, like one being from Kushagra. Like he's mentioned, just wondering what's an ideal in-memory database would be like. Like the most I know about Redis and other in-memory databases, I know the most use cases are caching, state management for stateful servers, and stream processing systems. Yeah, I think you've covered the different use cases as well, Paul. I think.
Yeah, by the way, I just wanted to add here that in-memory databases, currently, we will speak about it later when we will touch MemoryDB, but they also support, for example, vector search. So currently, they also support all kind of GenAI cases. So it's not only caching, it's a much more other cases that we see through the whole industry.
Oh, yeah. So let's look at a few more. We have Karan, who's joined from India. Thank you. Then we have Pradeep, who's joined from Bangalore. Yeah. Then the Rec one has mentioned he just cleared the SysOp associate. Congratulations.
Congrats.
I think this was on the first question. I think Rex one has put it like when you're trying to explain like Valkey, is it new Redis without a license?
Yeah. I mean, there's still a license attached to Valkey, but it's a BSD license, so it's it's very flexible.
Also, I want to mark that Valkey and Redis, it's two separate projects, and Valkey lives its own life. It doesn't depend somehow on Redis, so we can't call Valkey a new Redis, like, because they're just not connected anyhow currently, and so it's so basically, is it a new Redis without license? So no and no, it's not new Redis, and it has license.
Yeah. So there were questions around cost optimization and application scale. I think we'll be covering that as a part of your demo as well. Does Valkey support multi-threading?
Yeah, it does. This is what I mentioned, but like, you need to understand that it is not multi-threading in terms of command processing. It's basically offloading some processes that can be done on other threads to these IO threads that we start separately, because basically the fact that we have only one thread that is processing commands, that helps us to keep data consistent, and we don't want to lose this adding new threads. So we push everything that we can to other threads, but command processing is still single-threaded.
Okay. Yeah. Thanks, Maria, for that information. So now let's look at how are the AWS customers actually using Valkey? Can you give us some examples?
Yeah. So I mean, there's so many customers on AWS. There's a huge amount of use cases, but obviously very popular amongst games development companies. Maria pointed to some of these examples earlier with leaderboards, for example. You have customers using it for messaging services, caching. Some people are using our service MemoryDB as a durable in-memory data store, so for storing kind of documents, for example. That's just a few examples, and that I think, as Maria said, as we see more innovation now with generative AI, having the ability to store vectors within your in-memory data layer is really powerful as well, because that gives you the capability to work with things like embeddings and do things such as semantic caching. So you can effectively, if someone's asking a question, you can cache that query and then do a semantic lookup on that query the next time when you look up that data. So just kind of taking the meaning of the question and not really a specific value, which you might be doing if you're doing kind of a lookup on a key, a specific key for a query, or some sort of attribute that's coming into your application layer, for example. And Maria, you might have some more examples you want to point to.
Yeah, sure. For example, I know customers who use Valkey and Elasticache for Valkey not only as a place to store data and to get like a very low latency, but also kind of a processing engine. So for example, they do all kind of aggregations and like other stuff with the data using Lua scripts, which you can just pass to the engine and it will execute it for you, which is also very, very powerful. So I know like these kind of capabilities are used in all kinds of cybersecurity companies. They also like use this as a compute engine, not only as a database, because just Valkey provides this kind of capabilities. So basically, Valkey and Redis, and in general in memory databases, they're kind of a basic building block, right? So you have a relational database, you have your virtual machines run in your backend, and you have cache engine that you can leverage for different kind of workloads. So this is just very, very common, almost like all the customers that I'm talking with, they use Elasticache or other in-memory solution in their applications.
Yep. So, yeah, good examples. So you mentioned about Elasticache. So can you provide us more details about what Elasticache is about?
Sure. So Elasticache is a distributed caching service on AWS, and it gives you a way to run technologies like Valkey at scale, and it's a fully managed service, Prasad. So you can deploy Elasticache. You can choose an engine, either Memcached, Redis OSS, or Valkey. Deploy the service, and then connect your cache and start to integrate it into your applications.
Okay. So from an application perspective, are there any changes in code that they need to factor in while they move their data or consider Elasticache?
If you've been using Elasticache previously, and you switch to Valkey, as Maria said, Valkey 7.2 is a drop-in replacement for open source Redis, so it supports the same protocol, same data structures, things like TLS, ACLs are supported, so it's really a like-for-like experience. You can deploy a cache and then reconfigure your application to use that, or you could potentially migrate your data set within the AWS console to use the new engine. We also have a serverless offering as well, which is really interesting because it really kind of reduces the barrier to entry to creating an Elasticache cluster, so you can get started very quickly.
Okay. Yep, makes sense. So Lydia has posted the link for Elasticache as well. So here are the documents which you could refer by checking the link there. There was another question is, why would someone use a Valkey instead of a database for vector? I think the in-memory databases are very expensive.
Yeah, so if we kind of break that down into two kind of questions there, I suppose if you want to do vector search on with an in-memory data layer, that's going to be extremely fast. So that's the main reason for doing that. Obviously, if you might want to think about how you're working with your data. For example, if you're creating embeddings from a certain data set that's stored in S3, then you might just want to store some of that data as embeddings in the in-memory data layer. But then why would you use Valkey? Well, if you use it on AWS, you will save costs as well. So there's significant cost savings if you switch to the Valkey engine on AWS if you're using Elasticache or if you're using MemoryDB. So that's kind of two ways I'd look at it.
Yeah, I can also add to this that some Gen AI cases that require vector search currently, they also have the requirement to work real time. And if we start to speak something that is real time, so we need to see a very, very, very low latency. And for now, in-memory databases that support vector search, basically, this is the fastest solution for this kind of workloads. So there is always this trade-off of you want, okay, super, low latency, but you need to pay, or you can actually afford a higher latency, but it will be cheaper. This is the trade-off that the whole industry is facing now. So it's a great question, but it all depends on the use case and on the requirements.
Yep. Thanks, Maria. So yeah, now let's look at the demo part of it. Paul, so are you going to show us
Sure.
creation of the cluster? Is it?
Yes. So we've got two demos for the audience today. So the first one is to just very briefly show you Elasticache serverless and how easy it is to get started. I think my screen is shared.
Yep.
So, cool. So yeah, if you've got access to the AWS console, search for Elasticache, and then you get taken to this screen. And you can see here on the left hand side, you've got the different kind of caches.
So Paul, can you zoom in a bit, please?
I can.
Yep.
Is that better?
Yeah.
Yeah.
Great.
Cool.
Thanks.
Sure. So you can see here we've got Valkey caches, Memcached, Redis OSS, and other things like our global data store option. So if we want to get started with Valkey cache, we can just head into Valkey caches. We could say create new Valkey cache. And in this example, I can choose from either serverless or I can choose to design my own cache. So I'm going to stick with serverless. Let's put in a name. And you have the option to either pick Valkey 7.2 or the newer version, version 8, which includes the things like asynchronous I/O and the improvements to memory optimization. And then here you have the default settings. So, for example, we could see that we have our engine version, the availability zones that it's going to be deployed into, things like encryption in transit, encryption at rest, and whether we want to configure automatic backups and things like security groups. So in this case, it's just going to deploy into the default VPC in this example, but you can, there is a lot more configurability if you want it. And so you literally just click create and that will go and start creating that cache. I did create one earlier, which is running here.
Are there two deployment options? Is it, Paul? Like, is it the serverless one and what was the option there?
So you can choose between serverless Elasticache or
Yep.
you can design your own cluster. So if you design your own cluster, you choose the cache nodes that you want to power your cache, and then you deploy them into the relevant VPC. Yep.
Okay.
And then once you've got your serverless cache up and running, you can connect to it through the endpoints, and you can also, interestingly, create a compute connection. So if you've got an EC2 instance running within your VPC, you can click set up compute connection, and then that will automatically configure the security groups between the cache layer and your compute layer, so you can get started very simply. So,
wow, I didn't know about it. Each time I was running a separate EC2 with all the configurations from the scratch. Wow, very cool.
yep. So here's one that's running. So I did this earlier. Says connection already exists. But if I go over to my terminal here, I should be able to just put in the endpoint, and then you could see I'm now connected to my serverless cache on AWS. So it's very simple to get started, and you don't have to think about capacity planning. It's just a very simple way to get started. And obviously, if you're kind of using this for dev and test workload, then you're not paying when you're not using the service. You just pay for the data that's stored in memory.
Yeah, listen, I think it is just amazing because the most like pain that I hear from the customers that wants to start with their like fresh cache layer is how to do the right sizing. You have so many options. You have so many EC2 instance types that we need to choose. Then you need to decide if it is cluster mode enabled or disabled. How many replicas do you need? If sorry, how many shards do you need? Do I need shards? Maybe I don't. So all this is, these are all the relevant questions, but serverless just, allow our customers not to ask these questions and not to answer these questions. You can just have this one endpoint and just start running the cache, and the service will do everything for you. So I think, yeah, this is great if you just, start building and you need this, kind of a jump start. So try serverless next time instead of designing a new cluster.
Yeah, that's good to know. So do you just get an endpoint once the creation of the cluster goes through, and from an application perspective, it's just using the endpoint and getting started using it? Is that how it works then?
Yeah, you get an endpoint, and there's some really interesting technology behind the scenes with Elasticache serverless. So there's a kind of engine technology called Caspian, which creates a pool of warm nodes that are ready to go. So it's another kind of bonus with Valkey, actually. With the advancements that have been made in Valkey, it means that serverless can now scale faster as well. So if you opt for serverless, it can scale up extremely quickly, both vertically and horizontally, by bursting with the compute capacity that's already allocated. So there's bursting to support vertical scaling, and then it will scale out as well using this Caspian technology. And there's some really interesting technology in there, like a proxy which manages the connections between the client and then those requests that are being routed through to the cache nodes, which are using cluster mode. So like Maria said, you're still using shards and replicas within Elasticache serverless. You just don't have to worry about it.
Yep, makes sense. So right at the start, we mentioned about another service that also provides an in-memory database managed service. We mentioned MemoryDB. So what's the difference between Elasticache and MemoryDB?
It's a great question. First of all, both of them are in-memory databases. So yeah, how would you choose? The main difference is that MemoryDB is durable. So when we use Elasticache, so basically the data that we keep in memory, we don't have any promise that it will always be there. It's by definition, it's in memory. You don't expect it, to be 100% durable. Something can happen, and you have a partial data loss, or something went wrong with the node, which also happens sometimes, and the data is just gone. This happens. But MemoryDB actually solves this issue, and it uses the technology that is called the transaction log. So each time you send the command to the primary, it is saved synchronously to the transaction log, which means that now it can't be gone. It is just there. And if something goes wrong with the node that saves the data in its memory, so then we can just replay these commands again, and we will return to the same state where we were. So this is the main idea around MemoryDB service in comparison to Elasticache. So if we need to choose, we need to answer if we want our database to be durable 100%. And if answer is yes, so MemoryDB is the right choice in this case.
Okay. So if you want to make the data durable or have a use case where durability is the key requirement, then you would go for a MemoryDB implementation.
Yes, exactly. Mhm.
Yeah, that's great.
But it still supports different engines. You still can have already open source or Valkey inside. So it's all about the service around it. You still have the same core, like the engine, but the service around actually provides the whole durability and availability and so on.
Okay. Yeah. So Lydia shared the links in the chat regarding the MemoryDB as well. And yeah, I think there were questions about getting started. So she's shared the link as well. Another question was, do you have data tiering in the MemoryDB?
As
So
far as I remember, no. But let me check, okay? During the next question that Paul will take, I will Google and double check because yeah, this definitely exists for Elasticache, and yeah, you can put the data on the disk if you don't use it frequently, and this is what data tiering does. But I'm not sure that we have this for MemoryDB.
okay, yeah. And then let's head over to the demo for the MemoryDB. So Paul, it's going to be you again, right?
Sure.
Just maybe we can, yeah,
Are we
before we
talking
go into it,
architecture?
Oh yeah.
yes, we need to discuss like the architecture
Yeah,
because there was a cool release in the last reInvent. That's like the thing. So MemoryDB will get kind of a spotlight last reInvent because finally the solution for multi-regions were introduced, and it's a very cool, it's a very big update, and it is like many big customers really waited for it. It was super on demand, and yeah, like we will be happy to share the architecture and to discuss how it works.
Yeah. So let's head over to the architecture then, Maria. Let me. Yeah.
Yeah, let's just share the picture. Okay, so yeah, let me talk a little bit here. So what we see is basically three different regions. We see US West 1, US East 1, and US East 2. But they all are connected between each other. And in order to understand how the data flows, let's just simulate this flow and see how it goes. Okay, we have, yeah, great. We have a Valkey client that writes the data on US West 2. So we just send this command, set sun to be yellow. And sun is the key and yellow is the value. And what happened is, like what I already mentioned, we write this command in a synchronous way into our log, and only after that we return up to first of all to the cluster itself, and then to the client.
Yep.
Okay. After that, what's going on is that the transaction log from one region pushes this information to the clusters in other regions. So now all the other regions, you see US West 2 and US West 1 also got this orange rectangle, which is command set sun yellow. And now we have it everywhere. And this process is asynchronous. So the client on the US West 2 is not sitting and waiting while we are replicating it. We're still in memory. We still want to be fast. So we're just pushing this to other regions. Yeah, you can continue. Yes, great. And now we wrote this command into the transaction log in each regions and got acknowledged. Let's see what happens next. Just a second. This is not the end. Let's see why it is important. I explained why we need to look at it from the other region point of view, because we used to have a feature that we actually have it now for Elasticache that is called the global tables. So you have clusters in different regions, but basically one of the clusters, it is secondary. You can write there. You can use it only for reads. This feature in MemoryDB actually allows our customers also to write in different regions. So if we continue with this schema, so in US East 1, now we have a new writer that came and said set bag red, and we have a new data. And now we also saved it in the transaction log, received acknowledge, and returned it to the client. And then we again push this information to the rest of the regions. Great. And we copy it, and now the data is in all regions. It is durable, it is saved, and we can continue writing like this also in US East 2. There is no primary region. All of them are primaries, and all of them are communicating all the time to provide this multi-region architecture. So I think from here I can hand over this to Paul to show the demo, how it actually works. Paul created a very cool fancy demo.
Maria, before we head over to that, just to understand, the local writes you mentioned were synchronous, and the acknowledgement is back sent to the client once the local write is committed. Whilst
Yes.
Whilst the replication to the other regions, that's an async operation.
Yes, exactly.
Okay. And whilst the data is being read from a user connected or querying from another region, he'll get most up-to-date copy, though it's a async replication that's involved here.
Yes, it is async replication, which is still very fast, but the data there is not strongly consistent. It is eventually consistent because we use the async option between regions. So currently, if you read from the other region, you get the eventually consistent data. Mm-hmm.
Yeah. Okay. So there was another question, I think, whilst you were explaining the multi-region architecture is like, can you talk about the RTO and RPO use cases? So, like, when is it like you'll be using the synchronous replication versus async? Like for applications which have strict RTO, RPO requirements of say less than a few minutes, what is the configuration that they should be looking at?
Yeah. So with Elasticache, it's the data replication is asynchronous, and then with MemoryDB, everything's getting written to that transaction log that Maria mentioned. So this means that writes take a little bit longer on MemoryDB, kind of single-digit millisecond. But both services support backup as well, so that can be part of your your backup strategy to recover data. It all depends on your kind of tolerance around data durability, but both services offer 4 nines of availability, and then you can get up to 5 nines if you go for the multi-region version of MemoryDB.
Also, like if again, it all depends on on the requirements. There are like several options of how you can behave in case of disaster recovery, right? So first of all, yes, backups, then add replicas, so the data will be just replicated, right? The more replicas you have in different AZs, the better is for you. So if AZ fails, you can just fail over to other replica. But if this is not enough and you want to be safe in case of region failure, right? So yes, you start adding regions in adding clusters in other regions. So for Elasticache, it is Elasticache global data stores, and in MemoryDB, is also this option that we've just discussed, is multi-region, right? So if one region fails, you can always fail over to the other region. And in case of MemoryDB, you will not see any downtime because all the regions are basically primary regions, right? No one will not even notice that something happened. Like in case of Elasticache global data stores, yes, if there is a failover, so yeah, instead of secondary region, now it will become primary and so on. It will take a little bit of not exactly downtime, but you will see probably some latency there from the client side. But with MemoryDB active, this will almost be zero.
Okay. Yep. Thank you. So yeah, Paul, over to you for the demo.
Sure. So this is our second demo of the session. So if you're a developer, go and check out Amazon Q, by the way, 'cause it's a great way to kind of get started with building web-based applications, wireframes and stuff. So here we've got a blog where I've written a small, well, actually Amazon Q wrote a small article about MemoryDB, and then we've got a comment section. So for this application, let's just consider our users are in Tokyo and they're also in London. So we've deployed MemoryDB into 2 regions, so the Tokyo region and the London region. And basically this comment panel on the right is powered by a combination of a Valkey sorted set, and then the comments are hashes within Valkey. So this gives us the ability to have a collection of data, and then we've got metadata within the collection, which gives us more specific attributes like where the comment came from, such as the region, the actual message itself, and whether it's been liked. So I'm just going to do a Z add on this sorted set, which will add to the sorted set the comment ID, which links back to the hash, which I created earlier. So there's a hash in here for that comment, which has just popped up with my username, PM Ross.
Can you show again?
It
will be hard.
I can do a ZREM, I think. I can probably. So it's
oh, great. Okay, so yeah, now
yeah.
updated.
So it's gone. Let's add it again. So hopefully it'll pop.
Yay! We have your comment again.
So now let's go over to London, and I'm going to like that post. So I'll do a Z increbuy, which is to increase the count on that comment with that comment link within the sorted set. So if we do a Z increbuy, you'll see the heart kind of bounce there as we go up. We can do it again.
Can you add it to mine, because it's kind of everything going to
it's all going to mine.
No, I'm kidding. You don't have to do it.
if I get the shortened GUID for your comment, Maria, then I absolutely could. But it's
next time we show this demo, please add it to my comment.
So we see the data changing. So yeah, this is which one's that gone to? I think it's Prasad's comment. So I keep pushing Prasad's comment up. So it's basically to demonstrate how you can build these applications where your users can be in two completely different parts of the globe, but their applications can be writing and reading to the same data layer. So you benefit from not only the 5 nines of high availability, which we've already touched on, but you also get that really high performance read and write time for your local users, because that data is being replicated over the AWS backbone, and all the synchronization of that data is happening because of those conflict-free replicated data types. So Yeah, it's just a way to demonstrate this, and hopefully it will inspire some of the audience members to go and try MemoryDB multi-region themselves.
By the way, it's not only US regions now, right? Because in the beginning, when it was just released, it was only US regions, no? And now it's like you can choose regions where you want to deploy it.
Yeah, there's a lot of regions you can choose from now, Maria. It's really good.
Wow, cool. So yeah, here we had London and Tokyo. Cool.
Yeah, so there's more flexibility now in terms of deployment options. That's nice. Yep. So yeah, that's great. Great demo, Paul. Thank you. So now, if I want to get started on my in-memory database journey, we've discussed about the MemoryDB as well as the Elasticache. How do I get started on all of these things? Are there useful documents or labs where someone who wants to start on this journey can get started?
Yeah, so we've got samples which are available online, which focus specifically on Elasticache and MemoryDB. So that's our immersion day content. That's something that you could explore. Obviously, check out all the documentation. It's really thorough for both services. It's obviously a good way to get started, and then you can explore some of the options around the free tier for some of the smaller instance types. That's a good way to get started with some of the in-memory services on AWS. Maria might have some additional tips.
Yeah, I think that if you want to, like, for example, you don't have AWS account or you don't want to, deploy something in the cloud, you just want to be a hardcore developer and deploy something locally. So there is Valkey GitHub. So you can just, pull it from there and build and run the database locally. So it's also a pretty good way to start and to experiment with different data types.
That's a really good point, actually, because when I was working on the demo, I built it against either Valkey running on my MacBook or in Podman, which is a kind of open source alternative to Docker, and then you can just point at your Elasticache endpoint or MemoryDB endpoint when your application's ready to go into the cloud.
Yep, nice one. Thank you. So yeah, we have a few comments. Nice demo. So just on that point, you mentioned about this being available in the free tier. So both the services are available in the free tier. Is it like so the can the users get started with some minimal configuration in the free tier for both?
There's definitely for some of the smaller instance types.
Okay. Yeah,
it's
that
like
would be really handy to get started then.
Yeah, T family, like the smallest instance type, you can try to use using free tier, and it's true both for Elasticache and for MemoryDB.
Okay. Yeah. So yeah, thanks, Maria and Paul. It was really interesting. So I'll just quickly share some information related to our community page to our viewers. So this is the community page that we keep on updated with all our shows, the show notes, the video links as well. So you can hover over to the page, to get some more information about our past broadcast and in our season 1, season 2, where we have had different topics as well. We'll be adding notes of this today's episode as well into this and sharing with all of you. Again, all the links that have been shared by Lydia in the chat will all be a part of our show notes, which you could refer as well. So thanks again, Maria and Paul. It was really good to discuss the in-memory solutions and the Valkey open source innovations with you today. To our audience, thank you once again for joining us, and and I hope you found the show really useful. So do tune in next week at the same time, where we'll be covering another interesting topic related to data. So thanks once again, all of you, for joining us. Yep.
Thank
Goodbye.
you.
Thank you.
Thank you.
Thanks a lot.
Bye.
Bye.